This worksheet is going to teach you how to name aldehydes and ketones. This box table that you have up at the top of the page gives you the steps that you need to take to name an aldehyde on this page. Ketones will be on the next page. And then you have an example of naming a pretty tricky aldehyde. So we talked about the prioritization of functional groups. Aldehyde is the highest priority functional group that you have learned so far. That means when you are finding the longest carbon chain in the molecule, you need to find the longest carbon chain that contains the carbon-oxygen double bond. And when you number that carbon chain, you are going to number it so that the carbonyl group gets the smallest possible number, which is 1. So that makes it pretty easy. When you're locating the longest carbon chain and numbering it, you know that your aldehyde carbon is always going to be carbon number 1, and then you count out from there. So there we've got 1, 2, 3 for our second example. If our molecule has double bond, or a carbon-carbon double bond, or a chiral carbon that's showing its stereochemistry with wedges and dashes, then we always want to start the name of the molecule by indicating whether it's cis or trans or E or Z or R or S. And again, you can only do that if you can actually see the stereochemistry. So in this molecule, our example molecule, we can see that it's an alkene, and we can see the stereochemistry between carbons 2 and 3 is trans or E. We could choose either one. And so we want to start the molecule with the stereochemistry. For our practice molecule over here, even though carbon number 2, carbon number 2 isn't chiral. We don't have any chiral carbons. We don't have an alkene, so stereochemistry doesn't apply to this practice molecule. Once we get the stereochemistry written down, our next job is to locate and name our substituents the way that we normally do. So we're going to alphabetize them. And our example molecule has a chlorine substituent that's on carbon number 4, so there's our 4-chloro. Our practice molecule over here has a substituent on carbon number 2, and that substituent is a methyl. Once we get all the substituents named, then we are ready to name the parent chain. The parent chain is, like usual, it's based on the number of carbons. So since our example molecule has 1, 2, 3, 4, 5 carbons, that means that it is based off of the name pentane for 5 carbons. This particular molecule, because it has a carbon-carbon double bond, it's not a pentane, it's a pentene. And to name this molecule as an aldehyde, we drop only the E from the ending of the name, and we replace that with al. So this becomes pentene al. Again, we're only dropping the E and replacing it with al. We do have to locate the position of the carbon-carbon double bond. It's at carbon number 2, and we're looking here at 2 different ways that you can locate the position of the carbon-carbon double bond. You can say trans 4-chloropent 2-enal, or you can say trans 4-chloro 2-pentenal. You don't have to locate the position of the al, the aldehyde, because it is always going to be on carbon number 1, so it's implied. And we've seen that implied number 1 situation before. So let's go to our practice molecule. We've already named our substituent 2-methyl. This is a 3-carbon aldehyde, so that means that it's based off of the name propane. But we are going to drop the E and replace it with al. So this is 2-methyl propanal. Let's try a couple more examples. Again, with an aldehyde, because it's our highest priority functional group that we have learned about so far, the aldehyde carbon is always going to be carbon number 1, and we're going to start numbering outward. This molecule, we do want to number across the carbon-carbon double bond because it's easier to name the molecule if the carbon-carbon double bond is included in the parent chain. Let's go with our substituent first. We have on carbon number 3 a methyl group. This is a 1, 2, 3, 4 carbon chain, which is based on butane, except for this is not a butane, it's a butene. We can't just say butene, we have to say the location of that ene. So let's erase that and we'll call it 3-butene or but-3-ene. And then last but not least, because it's an aldehyde, we're going to drop that E and replace the ending with al. 3-methyl-but-3-ene-al, or you could say 3-methyl-3-butene-al. Let's look at our next one. The aldehyde carbon is always carbon number 1, and then we number out from there. Don't get excited. Don't think if we're just looking for the longest chain of carbons, don't get excited and go like this with your numbers. No, that's not allowed. You can't do that. When you are finding the longest carbon chain, the longest carbon chain either has to be a totally straight chain or it has to be a ring, but you cannot mix and match some straight chain, some ring. You've got to make a commitment to either a straight chain or a ring. And actually, you don't even get to decide. You have to go with where is the aldehyde group. It's on the straight chain, not on the ring. So the ring is a substituent located on carbon number 2. That substituent is called cyclohexyl, based off of cyclohexane. It's cyclohexyl. And then we're ready for naming the parent chain. This is a propane, but we're going to drop the E and replace it with al, 3-cyclohexyl propanal. We've got one more example. Carbonyl carbon is number 1. And here, when we have a choice of where to go with our longest carbon chain, always number across another functional group, like number across the triple bond. It's going to make the molecule much easier for you to name. So that means we have a substituent on carbon number 2, and it's a complicated substituent. That substituent is the isopropyl group. 2-isopropyl. We have a 4-carbon chain, so that would be a butane. It's based off of being a butane. But we do have a triple bond in it, which means that it's a butyne. And we need to say where that triple bond is located, so let's call it 3-butyne. You could also call it but-3-ine. And it's an aldehyde, which means that we're going to drop that last E and replace it with al. 3-butyne al. 2-isopropyl, 3-butynyl. It's a weird one to say. There are 3 aldehydes that you need to know by their common name. This little guy right here, its common name is formaldehyde. Its IUPAC name is methanal. Next little guy over, its common name is acetaldehyde, kind of like acetic acid. Its IUPAC name is ethanal. And the last one that you're looking at, you already know. This is benzaldehyde. But those are 3 very commonly used molecules, so you should know them by their common name.